Hello everyone, welcome to the second session of bubble sort. In this session we are going to learn how to code bubble sort algorithm in Python. Let's take the same example that we have covered in the last class and to recap the main idea of bubble sort. Okay, it was to compare, adjacent elements one by one and swap them if we find that they are not in order. They are not in ascending or descending order. Okay. Now here 15 and 9 are two adjacent elements and they are going to be compared. Now let me just see what is the index number of 15. Yes, of course it's 0. What about 9? It's 1. So if I name them as AJ and AJ plus 1, what would be J? Yes, J is going to be 0. So let me name these two elements as AJ and AJ plus 1. The adjacent elements are now given names AJ and AJ plus 1. J is actually the index number and you can see the index number is right now 0. Fine. So J and J plus 1, AJ and J plus 1 are compared and you can see if they are out of order, and you can definitely see here AJ is greater than AJ plus 1. So please you have to swap them. Cool. Now what should be done next? Yes, of course I have to jump to the next index number. So that means from 0 I have to take the position of 1 so that the element at index number 1 can be compared with the element who is in index number 2. So that means the J value has to be increased. So here J was 0, now here J is 1, so that A of 1 and A of 2 can be compared, right? So J is increased by 1 unit and here let us see, is it greater? AJ is greater? Yes, it is greater. So please swap them and after swapping jump ahead. So J is 2, it is incremented by 2. So now let me compare. No, AJ is smaller, no change. Now go ahead. So that means index value has to be increased. So here J is 3, 30 and 6 are compared. 30 is greater. Need to swap them, and of course let me move ahead again so that I can reach 30 and 4. So J is position 0, 1, 2, 3 and 4. So J has reached the value 4 and of course we need to swap here and swap, right? So you can see this is phase 1 where you can observe that the J values, the index numbers change from 0, 1, 2, 3, 4. So that means I can use a for loop, right, and execute these two statements. That means the comparison and the swapping, right? How many times? When J is 0, 1, 2, 3 and 4. So here for J in range 0 to 5 I have taken. What we have to do? Compare AJ and J plus 1 so that they get their correct position, right? But is this the final stage? No, right? It's a bubble sort. Repeat the same procedure again. So let me go ahead with the phase number 2. Again we start with the first position. That means if this is AJ and J plus 1, again the J is taken as 0. How many times? Let me check it out. Okay, these two are swapped. Go ahead. J becomes 1, right? 9 and 15, no change. J becomes 2, so index number is 2 here. 15 and 4 swap. And then going ahead, shall I move? Yes, 15 and 6 has to be compared. Fine. Shall I move ahead? No. Why? It's a bubble sort and you can see 30 has already reached its correct position. There is no point of comparing 6 and 30. So what is the final value of J in this case? Yes, it was 0, 1, 2 and reached 3, right? So one value of J is reduced, one stage is reduced for J. So here in this case you can see the loop ranges from 0 to 4. Cool. But what should be done? Of course, comparing the adjacent element and rearranging them if they are out of order. Now let's jump ahead to the next stage. Again the comparison is continued. How many times? Let me check out. Okay, compare, shuffle, compare, and of course shuffle, right? Shall I move ahead? No, because 15 has reached its position, right? So what is the final value of J's? J is 0, 1 and 2, of course. So my for loop will range in this case 0 to 3. Fine. So observe this. In first iteration J was 4, second iteration the upper limit of J was 3, and in third iteration J has taken 2, right? Fine, let's move ahead. Now iteration 6, swap. Next J is 1, so this is index number 1. Okay, again swap. No need to move ahead because 9 has already in its correct position. Okay, so the shaded part definitely makes you clear that no need to compare now. I have put a partition also to understand where I have to stop. So in iteration 4 or the phase number 4, you can see the J ranges from 0 and 1, so the range value is from 0 to 2, right? Okay, let's move ahead. Okay, I think this is the last comparison. As you can see here, 6 and 4 are swapped. Do we need to proceed further? No, here J has taken only one value, J equal to 0. So, but we have done the comparison and the shuffling. That has to be of course done in bubble sort. But how many times? J ranges from 0 to 1. Okay, so now let's wrap up everything what we have observed so far. We had 6 elements, right? And how many phases did I make out? This was the last stage. So how many phases, how many times I had to repeat this entire stuff? It was 5 times. So in phase 1 or iteration 1, we observed J ranges from 0 to 5. Cool. In stage number 2, J ranges from, yes, 1 step was reduced. Similarly, if you observe these J loop, you can see as the iteration or the phase increases, the number of comparisons of the J is decreasing. So let me just depict this phases or iteration by using a loop. How many times the iteration occurred? 1, 2, 3, 4, 5 in case of 6 elements. So I have put a I loops representing the iteration, right? Representing this iteration. So for I in range 1 to n, what did we do? When I was 1, J ranges from 0 to 5, right? Now if I generalize this 5, what is 5? 5 is actually 6 minus 1. 6 is what? N, the number of elements. So J ranges from 0 to n minus 1. When I is 2, it becomes n minus 2. When I is 3, it becomes n minus 3. So that means the J range is actually J ranges from 0 to n minus I. Now observe this. I is 1, it becomes n minus 1. When I becomes 2, it becomes n minus 2. When I is 3, it becomes n minus 3. And you can see now the I and J are perfectly fine. Now what is left out? What did we do in the J loop? Yes, the comparisons of AJ and AJ plus 1 and swapping them in case they are out of order. Fine. So I think now the logic is clear. Now let's do some coding. Fine. Okay, let me start with the bubble sort function. And let me count n, which is actually the number of elements, length of A. And let me start the for loop. What was I? I was how many phases? Yes, 1 to n, right? Okay. And then J for J in range 0 to n minus I, of course. Yes, of course. N minus I colon, and then what was J loop having? If AJ is capital AJ is greater than AJ plus 1, right? So compare the adjacent element AJ and J plus 1, J is smaller, J plus 1. And if I find AJ is greater, then you have to swap them. So please swap AJ and AJ plus 1, AJ comma AJ plus 1 is equal to AJ plus 1 comma AJ. Fine, so they have swapped. Okay, now let me see what is the status of my array, okay, after each iteration. So I'm going to use a format function here. So for array after and ith iteration, first iteration, second iteration, so first bracket represent the iteration I, comma, and the second bracket is your array. Okay, so array after ith iteration is A. Fine. Okay, cool. Now let me just check it out how my function is going to work. Bubble sort. Let me give some elements to it to 12, 6, 9. Okay, and 0. Fine. Okay, save it and execute. Cool. So here you can see there were 6 elements, and within 5 iteration I got all the elements sorted. And you can definitely see the largest element came here and the second largest element, one by one. All the elements are sorted. Fine. So that brings us to the end of today's session. Hope you followed it well. But before you leave, don't forget to click the like button and share. See you soon with another kind of sorting technique, insertion sort. For the time being, keep practicing, enjoy learning, and of course, happy coding.